So here we have then the DC voltage, and on the oscilloscope we can see the blue trace is the 1600 megahertz and the red trace is the 800 megahertz. We just excited the diode or the TVS with the red curve, with just the low frequency, and the non-linearities created the second harmonic. As you can see here, as I move the amplitude of the DC level, we have of course a higher degree of harmonics, more energy is created as we go up with the amplitude of the 800 megahertz signal. But in regarding to the phase, as you can see here, there is a flip right when we cross the zero. As you can see, the phase doesn't change that much. This is in contrast to the diode TVS, but we see the flip. Just a quick overview. This is the power source, 800 megahertz, goes to this power divider, resistor made. One leg goes directly to the oscilloscope, that's the signal we were watching right now, and the other leg goes to this power amplifier. The power amplifier output goes through this attenuator and it reaches this duplexer. The duplexer, this is the port, the low frequency port, 800 megahertz. The common port, we have our TVS and the bias circuit, and the output goes directly to this signal analyzer, which just shows the amount of power we have passed through the diode. And here, this is the important part, the 1600 megahertz output of the duplexer goes to this small box, which has inside a filter, a handy-made filter, and also an amplifier. All of them are shielded, double shielded by this box, and whose output excites the channel number 1, which is the blue signal here on the oscilloscope. That's basically the setup. What's important here, what was the most complicated thing, was to get a good isolation on the high frequency channel. We could have a nice isolation between the 1600 and the 800. 800 signal is much larger, of course, than the 1600, so it was hard to see this degree of cleanness on the 1600 megahertz. We can also see the fast Fourier transform here. Let's see the math. As you see here, this is the fast Fourier transform. We have also, because this oscilloscope goes all the way to 4 gigahertz, we can also see the 1.6 and the 2.4 signals, the other higher order products, right?